Hello everyone, welcome back to SS classes. Myself Shashank Srivastava. Today I will discuss class 9 chapter, that is number system. What is number system? Suppose we all know about the numbers like 1, 2, 3, 4, 5, 6, 7, 8 up to infinity, or we can say it minus infinity to plus infinity. Here infinity is nothing but here infinity is nothing but it is a way to represent a number whose existence is not present but it can be imagined. Thus we can conclude that there are lots of numbers in the real world through which we can play with them. Let's discuss first numbers, that is called the natural number. First number is natural number. It is denoted by n. It is denoted by n, and we can say that if a number starts from 1, 2, 3, 4, 5, 6, 7 up to dot dot infinity, then it is called natural number. Why we are saying that 1, 2, 3, 4, 5, 6, 7 up to infinity is natural number? Because if we see the series 1, 2, 3, 4 up to dot dot infinity, here common difference between two numbers is 1. That is, it forms an AP, arithmetic progression. What it means that if we see here, if we see any two terms of these progression, like 1 comma 2. Here common difference is 1, and further all these terms have also common difference is 1, and this phenomena taken as further. That's why this series, this progression becomes infinite. That's why we can say that smallest natural number is 1, and biggest natural number can't be defined right now. Thus, we can conclude that from the series of from the progression of arithmetic natural number, we can conclude that natural number start with 1 and end with infinite. This is the definition of the natural number. Note: smallest natural number is 1. Second one is biggest natural number can't be defined. Here we can use 1 from the set of natural number. Here also we can use from the set of natural number. This is the summary about natural number. Let's discuss another number that is called the whole number. Second one is whole number. A number starts with 0, 1, 2, 3, 4, 5, 6 up to dot dot infinite, then it is called whole number. Whole number. It can be denoted as double. Then we can conclude that from the number line system, if we take number lines, we can find some conclusions about natural number as well as whole number. Let's discuss about it. This is a line. Zero, 1, 2, 3, 4, 5, 6, 7 up to dot infinite. Here -1, -2, -3, -4, -5, -6 up to dot infinite. Here we can say that 1, 2, 3, 4 up to infinite. This set is called natural number. And from 0 to infinite, this set is called whole number. From the set of the whole number, we can say that from the set of whole number, we can say that smallest whole number is 0 and biggest whole number can't be defined in this era. Thus, we can also conclude this statement via diagram. Here, it is a set of natural number. It is a set of whole number. It start with 1, 2, 3, 4, 5 up to infinite, and it start with 0, 1, 2, 3, 4, 5 up to that infinite. From these two figures we can conclude that first of all the natural number is whole number. Whole number. For example, if we take a set 0, 1, 2, 3 and set B 1, 2, 3, then we get from these two statements from these two sets that set A contains all the elements of set B, but set B cannot. It means that set A contains all the element of set B and set B can't be take all the elements of set A. Thus we can say that set B is a subset of set A. We can discuss all the symbolic representation of set in chapter of set theory. Here we can generally use a symbol of set representation. Don't be panic about it. We will discuss about it in set theory. Now we can conclude from these two diagrams. Now we can conclude from these two diagrams, which is shown below, This is a set of natural number. This is a set of whole number. Now, conclusion is that this is a set of a whole number. This is a set of a natural number. From these two figures, we can conclude that all the whole numbers is a part of all the natural number is a part of a whole number, but vice versa is not true. It means that here we can write some true and false statement through which we can easily identify which statement is true and which statement is false. First statement is all the natural number is whole number. This statement can be true or false. Here we can see from this diagram, we can see from this conclusion, here all these natural numbers belongs to whole number. That means it represents that given statement is true. But if we can write all the whole number is natural number. Can this statement is true or false? From this diagram we can clearly see that all the whole numbers are not a natural number, but all the natural numbers are whole number. Thus statement 2 is false. This is the concept of the whole number and the natural number, which we discussed in this diagram. Now let's discuss about integers, and third number is integer. Now let us start discuss about integer. We will discuss it on numbers lines. It can be represented as z, always we represent it caps lock of z, that means capital Z, or in some books it will also represent as, or it can also represent as I. Now we will discuss about integer. Now take some example on number lines. This is the number line. This is 0, 1, 2, 3, 4, 5, 6 up to infinite. Here also we can take it negative form. -1, -2, -3, -4, -5 up to -infinity. -infinity and plus infinity. It is not a number. It is a way to represent an imaginary number whose existence is not present in the real world, but it can be exist. Okay. Now we have already discussed about natural number, which starts from 1. This is called n. N denotes for natural number. If we start from 0, this is called whole number. Okay. If we denote from minus infinite to plus infinite, this is called integer. Z, which can be represented as Z. From minus infinite to plus infinite, we have large amount of numbers, and all the numbers which comes between minus infinity to plus infinity is called integer. Let's take an example through which we can discuss very properly. Suppose from these below number lines, we have concluded that we have 3 numbers. First is natural number, second one is whole number, third one is integer. This is the number line: 0, 1, 2, 3, 4, 5, 6, 7, 8 up to infinite, and here is also -1, -2, -3, -4, -5 up to -infinite. Here it starts from 1. It is called natural number. Denotes by n. and starts from 0, this is called whole number, and starts from minus infinite to plus infinite, it is called integer. Now, from these number lines, we can conclude above that all the positive numbers start from 1, positive numbers starts from 1, it starts from 1. Whole number starts from 0 up to infinite, 1 to infinite, and integer minus infinite to plus infinite. This is the small bracket. It means that we did not conclude minus infinite to and plus infinite. We only conclude all the numbers which is lying between them. Okay. Now, what we have get from this diagram, we will discuss it. Thus, we can conclude that. What we can conclude? Conclusion. Conclusion. This is the integer. This is the whole number. This is the natural number. All the natural numbers are whole number. All the natural number is integer. All the natural number is whole number. All the whole number is integer. But we can't say that all the whole numbers is natural number. Some whole numbers are natural number, and we can also say that some integers are whole number. Some integers are natural number. But we can't say that all the integers are natural number, all the whole numbers are natural number. From this figure, we extract some information which is very important for you. Please note it down. First one is all the natural number is whole number. This statement is true because all whole number contains the natural number, because whole number contains the natural number. Thus we can say that this statement is true for all cases, not for a particular cases. It is true for all cases. It means for all. This symbol represents for all. Okay. Now we can't say that all the whole numbers are natural number. We can't say that all the whole numbers are natural number. We can't say that all the whole number are natural number. But we can say that some whole numbers are natural number that is only those elements which are present in n, that is only those numbers which are present in n. Please note it down, and I will discuss more about it. Let's try to take another notes, that is third point. I will erase it. Third point is all the natural number is integer. This statement is always true for all. Fourth one, all the integers are not natural number. All the integers are not natural number. This statement is always true for all. This represents for all. It represents for all. Now we can also find some conclusion from this diagram. Some integers are natural number, or we can say that some integers are natural number. Or we can say that this point is always true for all condition. Sixth point is all the whole numbers, all the whole number is integer. But 7 point, this statement is always true for all. All the integers are not whole number. It is always true for all conditions. Thus, we can conclude from this figure 7 points. You can remember it. It will be very helpful in your upcoming examination like Polytechnic, JEE, whatever you want to go. Then we can understood it very properly from this diagram. Now we will discuss it on number line. Let's see. This is number line. Zero, 1, 2, 3, 4, 5, 6, 7, 8, up to infinite. -1, -2, -3, -4, -5, -6, -7, up to dot dot minus infinite. It is plus infinite. Here, from minus infinite 2 plus infinite. It is called integer, which is denoted as z. Here 0. 0 is called 0. 0 integer. From left side of 0, these portions are called minus infinite to minus 1, or we can say that minus 1 to minus infinite. This portion is called negative integer. And from 1 to infinite, this portion is called positive integer. Positive integer, or we can say that natural number. Thus, we have three types of integer. Thus, we have three types of integer. Three types of integer. First one is positive integer. Second one is negative integer. Third one is zero integer. Positive integer is also known as natural number. Okay, this is the integers concept through which you can very easily adopt all the things. Now you can very easily understood what is integer, what is positive integer, what is negative integer, what is zero. Now we will discuss some more questions regarding natural number, whole number, and integers. Now let's look some more views on number lines. Okay, from 0 to 1, from 0 to 1, we have large amount of the numbers. That means infinite number. We can see that from between 0 to 1 we have infinite numbers. That is 0 to 1 we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 up to dot infinite numbers. It means we can, if you take, for example, if you take 0.1, if we change it in fraction form, what we can do? 1 by 10. This portion is called numerator. This portion is called denominator. And this complete form known as fraction. And this fraction is called rational number. Thus, we can arrive a new number that is called the natural number. Then what is natural number? Fourth one is rational number. A number which can be represented in the form of P by Q, where P and Q are integers and Q not equal to 0. It means that if we say, for example, 2 is rational number or not, rational number or not, what you can say, 2 is rational number or not. We can say that here every number is represented in the form of P by Q. For example, 2, here always its denominator is always 1. If a number whose numerator is present, then their denominator will also be present. Then we can say that 2 is also a rational number, because it can be represented in the form of P by Q, where 2 is also an integer and 1 is also an integer, because 2 is positive integer and 1 is also positive integer, and positive integer is the form of an integer. That's why we can say that it is a rational number. Okay. If we choose another example, like for example 0 is rational or not, rational or not. We can say, what do you mean about 0 is rational or not? Is it rational or irrational or real or natural, whatever you want to say. 0. Let's see. Here 0. It is a numerator and its denominator. Every number, if it is a simple form, like as in a natural number form, or we can say that it is a whole number form, its denominator is always present. Here also a denominator is 1. Thus we can say that the 0 is a rational number, because it is a form of P by Q, where P and Q both are integer. Here P equal to 0 and Q equal to 1. And P and Q both are integer, because 0 is also integer and 1 is also integer. That's why we can say that the 0 is a rational number. Now, if we say another example, what we can say about it? Let's start with another example. If we say 1 by 0, can you say about it? It is a rational or irrational? Rational. It is irrational or irrational? It is rational or irrational. What we can say? Suppose here 1 by 0, it is also a form of P by Q. From our definition, we can say that it is a form of P by Q, but from the definition of but in our definition denominator can't be 0 but in our question denominator is 0, which is contradict our supposition, which is contradict our supposition. Hence we can't say that 1 by 0 is a rational number. Okay, is it clear? Am I able to explain from my side? Okay, let's try to some another example. What you can say about it? Suppose if we have minus 1 by 2, it is rational or irrational? What we can say about it? Here it is also a form of p by q. And p here p equal to minus 1, q equal to 2, then and q not equal to 0. Thus we can say that minus 1 by 2 is a rational number. Rational number. Let's take some another example. What you can say about it? For example, 1 to the power 0 by 2. Is it rational or irrational? What do you mean about it? Here 1 to the power 0, it is a, suppose here x to the power 0, it implies that 1. If we expand the power of x is 0, then it implies its value equal to 1. Apply these things in above question, we get that 1 to the power 0 equal to 1. That is 1 to the power 0 by 2 becomes 1 by 2, and here 1 is p and q is 2 and p also integer, q also integers. That means it implies that 1 to the power 0 by 2 is a rational number. Rational number. Is it clear? Okay. Let's try to some another example. One by root 2. Is it rational or irrational? Here p equal to 1 and q is equal to root 2. Here p is integer, but q is not q equal to root 2, which is not an integer. It is an irrational number. Why it is an irrational number? Because its value, because root 2 equal to 1.414 and its value is not a fixed. It is vary up to we will discuss about the value of root 2. Now you can here only here you can know about root 2. Root 2 is an irrational number. Irrational number. Irrational number. Numbers which can't be represented in the form of p by q is called an irrational number. We can discuss about it further. Here you can only assume that here q equal to root 2. Root 2 is a irrational number. Because its perfect square is not possible. That's why we can say that it is an irrational number. We can also discuss about it terminating and non-recurring, terminating but recurring, non-terminating but non-recurring. We will also discuss about it further. But here you can only assume that the q equal to root 2 is an irrational number because it is not a perfect square number. That's why we can say that it is an irrational number. P equal to root 1, p equal to 1 and q equal to root 2. That's why we can say that the p is an integer, but q is not an integer. That's why we can't say that it is a rational number. That's why 1 upon root 2 is not a rational number. Rational number. Or we can generalize it. We can that all the forms, all the numbers which are of the form of root p by q or p upon root q or root p upon root q are not rational. Rational number. Thus we can conclude that all the numbers we have discussed that natural number, whole number, comma, integer, is also known as rational number. Thus, we will relate it with the diagram. We will relate it with the diagram which is shown above. This is a natural number, this is a whole number, this is an integer, this is a rational number. We can conclude that this is rational number, this is integer, this is whole number, this is natural number. From this diagram we can conclude this diagram: rational number, integer, whole number and natural number. From this diagram we can also conclude that all the natural numbers are whole number, all the natural numbers are integer, all the natural numbers are the rational number. Or we can also say that all the whole numbers are integer, all the whole numbers are the rational number, all the integers are the rational number, but all the rational number are not integer, all the integers are not whole number, all the whole numbers are the not natural number. From this diagram you can also clear all your concept if you studied it very properly. Okay friends, we will discuss further in next classes regarding the irrational number. Now thank you for watching it. Okay, thank you.